Hello, my name is Zach Gatos, and this is a portfolio video for my virtual reality project that I've been working on in my free time outside of my college courses. I've been working on this project named Eidolon as the programmer and game designer with the help of Dr. Wallace Lodges, artist Emily Harris, and level designer Elena Ricard, who have since graduated. Eidolon is an asymmetrical virtual reality versus PC game where 4 PC players on mouse and keyboard are pitted against a single player using virtual reality. The goal of the PC players is to get to a relic surrounded by red, green, and blue force fields that can be unlocked by buttons corresponding to those colors. 3 PC players are assigned a color for which buttons they can press, but they are unable to see colors on the buttons. The 4th PC player is able to see all the colors on the buttons and must point them out to the other players. PC players must cooperate with this special player, as the buttons will periodically swap colors and a force field will only be down for a certain period of time after a button is pressed. PC players must do all of this while avoiding being sent to jail by the VR player. To help with completing their objectives, each PC player can choose a single ability before the start of the match, such as high jumping, invisibility, fake player, and more. The goal of the VR player is to prevent the PC players from getting to the relic before the game timer runs out, or by sending them all to jail. The primary game mechanic that the VR player uses is a frisbee they can grab from a pouch at their waist. After grabbing a frisbee, they can throw it, apply force to the grip on their index controller, and pull their hand back to teleport to the frisbee, inheriting its location and velocity. And this is slightly different on other controllers. The VR player can use this to set traps and move around more quickly. Alternatively, they can grip the index controller while holding the frisbee and punch forward to shoot a laser beam that will send PC players to jail if they run into it. As there is a short timer to the lasers, they are not used to directly hit players, but rather for making PC players run into lasers and for trapping them. The lasers will stay in place for about 10 seconds after they are shot, and there is a particle effect cooldown to the teleporting mechanic, making it so the VR player can only have 3 of these effects active at any one time. Another way the VR player can send PC players to jail is by grabbing them. Right now, the core game mechanics are finished, with the exception of some polish, and the art obviously needs a lot of work. But I wanted to focus on programming since that's my forte. I also wanted to highlight some things I learned and some solutions I'm particularly proud of. This was my first major project using virtual reality. I'm really passionate about VR, and creating this was my way to play VR games with my friends who are less interested in VR. I also wanted to create some interesting VR interactions that relied more on motions than controller buttons for immersion. This project was my first dive into networking and UI, although in my coursework I've since gotten more experience in those areas. The final thing I'm most proud of are the AI PC players. We figured we would need them if we didn't have enough players for a match. The AI is not true AI, but instead uses a behavior tree for making decisions. Decision making is decentralized, and they communicate to each other through events. The most challenging issue with the AI was how to make them avoid the VR player. They use the A-star pathfinding algorithm on a navigation mesh. While it is easy to tell the AI to get from point A to point B, it's more challenging to do that while avoiding the VR player on their route. To solve half of that problem, nodes on the navigation mesh around the VR player had to have a high cost of traversal independent of the distance cost of traversal. A-star would calculate a path avoiding these nodes except when the target destination is within the nodes or the AI is already within the nodes. Navigation mesh nodes couldn't be too small because although more granularity would improve pathfinding quality, it would hurt performance searching through too many nodes. To get around this problem, I made a system where the AI would avoid an elliptical radius around the VR player. The front of the ellipse is the direction the VR player is facing, so the AI would get closer to the sides and back of the VR player and stay far away from the front, where the VR player is most likely to see them and chase after them. If a calculated path intersects with the ellipse, the AI would move to locations on the border of the ellipse until the calculated path no longer intersects it. Another issue was if players are expected to communicate button locations with one another, How would the AI be able to communicate to a player and vice versa? The solution was if there weren't enough players to fill a room, one AI would have to play the role of the special player that points out the colors of the buttons by running up to a button and sending a message through text chat that they are near a button. This project was very challenging yet rewarding work, and I'm not sure where it will go from here. For now, I'm starting work on a new virtual reality game that will incorporate VR and game AI in different and exciting ways from this project, so keep on the lookout for that. I'll post a future video on that when I've made more progress.